In this tutorial, we are going to see how we can conduct analysis of covariance, which is a general linear model statistical procedure to test the difference between two or more groups in terms of a dependent or an outcome variable controlling for the effect of covariate or confounding variable, which is usually continuous. I'm going to walk you through the way we can do the analysis via spaces and the way we can check the hypotheses, the null hypothesis and the alternative hypothesis, and also the interaction effect between the dependent and independent, let's say between the independent and the covariate variables. So this is the data and we want to run the ANCOVA. We go to analyze, then we go to general linear model, then univariate. Then I will just put the independent variable, which is here education, into the fixed factor. Then I will just put the other variable, which is the dependent variable, let's say the first action here, and the covariate, let's say, which is age, in this box. Here for the model, I will just keep it for factorial. We have build terms and build custom terms in case I want to customize it. And so here include intercept in model. I can just check it. For the contrasts, I can just keep this. I can choose here in case I want to have any contrast. I can choose one, but I will just keep that as none. Then for the plots, in case I want to visualize the results, so I can just put this factor in separate plots or separate lines or horizontal axis depending on what I want to have. So click continue. Then for the estimated marginal means, here I could just do that for, let's say, education or overall model. So here I need to display the mean, and here compare mean effects, and here I could just choose either, as I told you, the LSD, less significant difference, or the Benhima test. So I will just choose the Benhima, which is most robust to change here. Then for the save, in case I want to save, let's say, new variables depending on the results, like Cook's distance, leverage values for diagnostics, in case I want to check some assumptions like outlier, normality, among others. So I could just see them here, or linearity. So I don't want to check that for now. I just go to options here. I could just take descriptive stats. I can estimate put the estimates of effect size, and also I could just check the Levenes test of homogeneity or variance, which is one of the assumptions of this ANCOVA test in general. So here I will just click continue. For the bootstrap, I don't need bootstrapping for now. So bootstrapping can be powerful in case we have data that is not normally distributed and we want to run bootstrapping at this default sample of 1000. So it will just take this sample and multiply it by 10,000, or just looking for different groups to see which one will work better. So just click continue. I don't need that. I will click OK. So this is the output. Here we have between subject factor. So ANCOVA and ANCOVA are considered what we call between subject factors, like between groups. In this case, education, here we have the codes and we have their labels and we have the sample size. Then the descriptive stats, we have the dependent variable. We have the dependent variable, which is action, and we have the mean score of each group along with the standard deviation and the sample size, in addition to the Levenes test of quality of error variances, which is not statistically significant. And here it includes this design of intercept plus age plus education, which is here the covariate, and the independent variable, as I told you. And this is the test of between subject effect. So here the dependent variable is action 1, type 3 sum of squares. You could see here the intercept, the age, the education, along with their corresponding values and sig values or p-values. See, the p-value here is not statistically significant since it's not equal to or below 0.05. So here we could say that there is no statistically significant difference education with the control, like with the covariate of age in terms of the first action. So this is just the estimated marginal mean. Since there is no statistically significant difference here, I could not just go for the pairwise comparison for the post hoc test, because I could just resort to the post hoc test when I have statistically significant difference here, but I don't have it. I may not proceed to the post hoc test. There's just one with regard to the intercept, but that could be just one remark that we could add, and that's it. So this is the univariate test, and the partial eta squared, the sig value, the f value, the mean square, the degrees of freedom, and the sums of square. So these are all the statistics that are produced by ANCOVA, and this is how we can go about interpreting the results. So if you have questions or remarks, do not hesitate to post them below. See you soon. Bye for now.